Whoop. Okay, the first operation is combining like radicals. It's extremely similar to combining like terms. So, like terms have the same variable of the same power. Like radicals have the same radicand. So, something like 6 times the square root of 11 and 9 times the square root of 11 would be a like radical. And so, you're able to combine those by just combining the coefficients of 6 and 9. And what you're doing there is you're using the distributive property to combine. So here's a different example. 7 times the square root of 2 minus 8 times the square root of 2. How the distributive property comes in is in your head you're doing what's in parentheses. You're combining the coefficients, which are 7 and negative 8. And 7 minus 8 is negative 1. So the simplified version then would be negative 1 times the square root of 2. Up here with that first example, that would be 15 times the square root of 11 as the simplified form because you would combine 6 and 9. Sometimes you have to simplify first before you can combine the like radicals. So let's look at this example of 4 times the square root of 7 plus 2 times the square root of 28. I do not have like radicals. However, I'm recognizing that 7 is a factor of 28. So I can bust 28 up to where it has a square root of 7 in there. So essentially, I'm going to be simplifying 2 times the square root of 28. So I'm going to go ahead and bring down 4 times the square root of 7. And 2 times the square root of 28 can be broken down to be 2 times the square root of 7 times the square root of 4. Now, before I can combine these like radicals, I have to do this multiplication over here. I have to do this exponent. The square root falls under exponents in order of operations because it's a power of 1/2. So, square root of 4 is equal to 2. So then I can take this 2 and multiply it by that 2. Therefore, 2 times the square root of 28 is simplified to 4, oh I forgot that 7, times the square root of 7 because square root of 4 is 2, 2 times the coefficient 2 is 4. Now I'm ready to combine those like radicals because that's the adding part of order of operations. I combine their coefficients, 4 and 4 combine to be 8 times the square root of 7. When multiplying radical expressions, this can be done a couple of different ways. So if you have a monomial times a binomial, a one term outside the parenthesis times 2 terms on the inside, you're going to use distributive property. So I'm going to multiply 2 times the square root of 2 times square root of 6, which would be square root of 12. Plus, I'm going to multiply square root of 2 times 5. The 5 goes in front of the radical, 5 times the square root of 2. Now I need to make sure none of these can be simplified. Square root of 12 can be simplified because I can break that down into square root of 4 and square root of 3. The reason I did not do square root of 6 times square root of 2 is because neither of those are perfect square factors. 4 is the perfect square. So what that allows me to do is simplify square root of 4 as 2. So I'm left with 2 times the square root of 3. That is the simplified version of square root of 12 plus my second part there, 5 times the square root of 2. Those are not like radicals, so I cannot combine them. There is my simplest form. The other way that you'll be multiplying radical expressions is using the FOIL method. First outside, inside at last. I'm going to try to color code these for you. So our first terms would be square root of 6 times 4 times square root of 3, which would be 4 times the square root of 18. For the outside terms, that's going to be square root of 6 times 3 times the square root of 6, so it's going to be 3 times the square root of 36. Let's pick up a different color. Now for the inside terms, that's going to be negative. Let's make sure you get that negative. Square root of 2, negative 2 times square root of 3 times 4 times square root of 3, which is going to be negative 8 square root of 9. And then our last terms are negative 2 times the square root of 3 times 3 times the square root of 6, which would be negative 6 square root of 18. So you should notice that you have those like radicals here of 4 times the square root of 18 and negative 6 times the square root of 18. You should also be seeing that I can simplify square root of 36 and square root of 9. Let's go ahead and start there. So we're going to write 4 times square root of 18 plus 3 times 6, because square root of 36 is 6, minus 8 times square root of 9 is 3, minus 6 times the square root of 18. Square root of 18 and square root of 18 are like radicals, so I can combine those, which gives me negative 2 times the square root of 18. 3 times 6 is 18. And negative 8 times 3 is negative 24. Let's continue to do some simplifying here. Square root of 18 can be broken down into square root of 9 and square root of 2. Square root of 9 is 3. So I can multiply negative 2 times 3 times the square root of 2. And positive 18 and negative 24 can combine to be negative 6. And last bit of simplifying, negative 2 times 3 is negative 6 square root of 2, and then minus 6. Go ahead and box our final answer. We're so proud of all that work. And we're going to look at something called conjugates. Conjugates are the sum and the difference of the same two terms. So an example of that would be square root of 7 plus square root of 3 and square root of 7 minus square root of 3. This should look familiar to you because it's a difference of squares. The product of conjugates is the difference of the squares. So product is meaning that we're multiplying. So let's demonstrate this. Square root of 7 plus square root of 3 and square root of 7 minus square root of 3. So the first terms would be square root of 7 times square root of 7, which is square root of 49. Outside would be square root of 7 times negative square root of 3, which is negative square root of 21. Inside would be square root of 3 times square root of 7, which is a positive square root of 21. And our last terms would be square root of 3 times negative square root of 9, which is negative square root of 9. Let's simplify these. That would be 7 minus square root of 21 plus square root of 21. Notice those did not simplify because there are no perfect square factors. And square root of 9 is 3. So that would be minus 3. And I can simplify my like radicals because negative square root of 21 and positive square root of 21 will cancel, which leaves me with 7 minus 3. Now, I want you to notice that I'm left with the same numbers, 7 and 3, 7 and 3, 7 and 3. The difference is up here, it is square roots. Down here, it's integers. And actually, I should not have boxed that just yet. Oh me, that's a huge eraser. Because, of course, I can simplify that some more. 7 minus 3 is 4. So 4 then would be my final answer. Let's see how this can be used in rationalizing a denominator. If you'll remember, one of the ways that we looked at simplifying radicals was that you cannot have a radical symbol down there in the bottom. Let's put the tops on those houses there. So what I can do is, you were trained before, if that had been just 10 over square root of 7, is to multiply top and bottom by square root of 7. But if I do that, I'm still left with the square root of the 2 here. So I'm going to use conjugates. And just like before, whatever you're multiplying the top by, you're also going to need to multiply the bottom by. So I'm going to multiply the top by square root of 7. That's an awful 7. Try that again. Okay, square root of 7 plus square root of 2. I'm doing adding because it's the conjugate, meaning it's the opposite. Square root of 7 plus square root of 2. So on top, this is going to be like distributive property. I'm multiplying 10 by each of those. So I'm just going to leave it like this. 10 times square root of 7 plus square root of 2. Now on bottom, if you'll remember from our previous example, it's the difference of squares. So it gets rid of the square roots and I'm left with 7 minus 2, which is 5. Now if you wanted to go through and FOIL that out because you don't trust yourself that it truly cancels, do that a couple of times and then you'll remember it. So see how this is so much easier that I can see, oh, well, 7 minus 2 is 5 because it's the difference of those squares. I chose not to fully distribute that out because I anticipated that that denominator was going to be 5, and lucky us, those will simplify. 10 and 5 will simplify down to the whole number 2, and then I'm left with square root of 7 plus square root of 2. Now I'm ready to distribute those. And when I distribute that, I get 2 times square root of 7 plus 2 times square root of 2. My radicals have no perfect square factors, so it is simplified. And finally, let's look at solving a proportion that involves radicals. If you'll remember, to solve a proportion, you use cross products. So I'm going to multiply diagonally. I'm going to start by doing square root of 2 times 5 times the square root of 2. So that's going to give me 5 times the square root of 4. And then that's going to equal x times square root of 2 minus 1. I'm choosing not to go ahead and distribute that x because I want to keep that x isolated. If you remember solving an equation, your ultimate goal is to isolate the variable. So now I can divide both sides by that binomial, square root of 2 minus 1. Over here, square root of 2 minus 1. So that'll cancel here. Now on top over here, square root of 4 is equal to 2. So then I'm going to have 5 times 2. So I'm going to move over here. And I'm going to flip it around because I like having the variable on the left side. X is equal to 10 over square root of 2 minus 1. So if you remember, what's wrong with this is I have a radical symbol in the denominator, and that's not good. So in order to get rid of that, I'm going to rationalize the denominator, and I'm going to do that using a conjugate, which is going to be square root of 2 plus the square root of 1. Now the reason that I'm choosing to do square root of 1 is because that's the same thing as 1. Now I need that to be the square root in order for it to actually cancel out and for it to work as the conjugate, as the difference of squares. So on top, I'm going to have 10 times the square root of 2 plus the square root of 1 over, and how that's going to cancel out is I'm going to have 2 minus 1, and 2 minus 1 simplifies to the whole number 1, so then I don't really have a denominator anymore. And then on top here, that square root of 1 can be 1, so I'm left with 10 times the square root of 2 plus 1. And there you have it.